టీచర్స్ అండ్ మేట్స్ లైక్ ఈరోజు సెకండ్ అండ్ ఫోర్త్ గ్రేడ్ రికార్డింగ్స్ ఆల్రెడీ నేను పెట్టానండి. దాన్ని ప్లే చేయండి. ఫిఫ్త్ గ్రేడ్ వచ్చేసి జూమ్‌లో లాగిన్ అయితే అందులో ఫిఫ్త్ గ్రేడ్ బ్రేక్అవుట్ రూమ్‌కెళ్ళండి. ఫిఫ్త్ గ్రేడ్ వాళ్ళు. థర్డ్ గ్రేడ్ అండ్ స్పోకెన్ ఇంగ్లీష్ వచ్చేసి ఈ వీకెండ్ వస్తాయి రికార్డింగ్స్. యూ కెన్ ప్లే దిస్ ఆన్ మండే. సో సెకండ్ గ్రేడ్ ఫోర్త్ గ్రేడ్ వాళ్ళు జూమ్లోంచి లాగిన్ అవుట్ అయితే లాగిన్ అవుట్ కావచ్చు. వాళ్ళకి ఇంకా అక్కడ ఏం లేదు కాబట్టి. యా, థ్యాంక్ యూ అండి.
Okay, I'll be starting the class now. Um, this is fifth grade English and Math, Estimation and Figurative Language. First is math. Today we are working on something that all mathematicians do all the time before they solve a problem, which is estimation. Estimation means finding a number that is close to the exact answer, but it may not be the exact answer itself. By the end of this lesson, you should be able to look at a multiplication problem and quickly identify an approximation. Round numbers to make reasonable estimates, estimate the products, estimate the quotients, and explain why estimating the first is helpful. Estimating products is multiplication and estimating quotients is division, so basically you'll be learning to do
Ashita,
both.
even you can share it here also, Nana. So that just I'll have some opportunity to see whether how the things are coming up on the
Oh, share screen?
yeah.
Okay.
So I can compare both, like here and the YouTube stream how it is coming. I know.
It says that share screen is disabled.
Oh, sorry. Yeah, let me do that. Yeah, it should be good. You should be
Thank
good
you.
now.
Why estimation matters. It helps us check our answers, it saves time, and it helps us catch mistakes. It's also used very often in real life. Estimation is like a math safety net. If you estimate first, you already have an idea of what the answer should look like, more or less. So basically, if you estimate, you have a general idea of where the answer should be around, and it helps us catch our mistakes because when we do the exact calculations, whether it's close to the estimation or not matters because then we can see if we were right or wrong. Here are some real life examples. If something costs 19 rupees and I buy 3 of them, I know it is about 60 rupees, not 600. Also, if I divide 100 biscuits among 5 people, I know that each person will get around 20. Take 1 minute to answer this question and discuss with those around you. Why would estimation be helpful before solving a problem? Okay. The answer is that if you estimate the answer before calculating it, you will have a rough idea of what the answer should be around and be able to know when your problem solving process is wrong. Which answer makes more sense? 48 times 19. Is it A, about 80, B, about 800, or C, about 8,000? The answer is B, which is 800. Why? 48 is close to 50 and 19 is close to 20. So if we round up 48 to 50 and if we round up 19 to 20, 50 multiplied by 20 is 1000. So the 800 makes sense as it is closer to 1000 than 80 or 8000. Even without solving, we already know what doesn't make sense. 80 is way too small, and 8,000 is way too big. 800 is close to the approximation, which is 1000, and therefore 800 is the correct answer in the estimation here. Estimate means close, not exact. Use words like about or approximately. The exact answer will come later. When estimating, say that the answer is about or approximately. Do not say the answer equals because we are not finding the exact answer. Some examples could be 38 times 21. That is about 800. 196 divided by 6 is approximately 30. We don't want to say 38 times 21 is 800 because it's not 800. It's just approximately, it's around that number. It's not exactly 800. That's why we will say it is about 800. We can also say approximately. These words can be used interchangeably when estimating. When estimating, we have to know how to round the numbers in the equation up or down. Here are the steps. Look at the digit to the right. If it is 5 or greater, round up. If it is 4 or less, round down. Examples: 43 to 40. 43 to 40 is rounded down. That is because 3, this is the digit to the right, that's the first step. Then if it is greater than 5, round up. But it's not greater than 5. It's 4 or less because it is 3, right? 3 is less than 4. So we will round down to 40. We rounded down to 40 because it is easier to use. 40 is a friendlier number to work with rather than 43. It's easier to make estimations using these simpler numbers. You always want to either make it end in 0 or 5, preferably 0, because then it's easier to compute a good estimate. And like any number that ends in 0 and 5, they're easier to work with. Next, 67 would be rounded up to 70 because 7, first we'll look at the digit to the right, that is 7. Then, if it is 5 or greater, round up. It is 5 or greater, so we'll round up to 70. For this one, 198, the digit to the right is 8. Now, is 8 greater or less than 5? It is greater, so we will round up to 200. Well, originally we could round up, yeah, we will round up to 200. Now it's your turn. Round these numbers. The answers are right here. 72 would be rounded down because the digit to the right is 2. 2 is less than 4, so we are rounding down to 70. In 405, the digit to the right is 5, but we will round it, instead of rounding it up, we'll round it down because it's very, very close to 400. So it's easier to work with a number like 400 rather than 410, right? So we can also round it to 400. You see, in estimation, it doesn't have to be perfect, meaning your rounding doesn't have to be perfect either. It just has to be as close as possible to the original number. Next is 19. 19 is close to 20, so we will round it up to 20. Next, round each number is the first step. Then you will multiply the rounded numbers together. The third step is to use the word about or approximately. You are estimating products here, which is multiplication. The first example is 38 times 21. Whoops. The first example here is 38 times 21. We will round 38 to 40 because 8 is the digit to the right. 8 is greater than 5, so we will round it upward. That is 40. 21. The digit to the right is 1, and then 1 is less than 4, right? So we will round down to 0. That makes it 20. 40 times 20 equals 800. So the answer is about 800. We are not trying to be perfect. We are trying to be reasonable. Could the exact answer be slightly higher or lower than 800? Discuss with the people around you, talk to your classmates, and decide whether it can be slightly higher or lower. Time is up. We are not. Okay, the answer is the exact answer would be a little higher than 800 because both the products were rounded upward. 38 was rounded up to 40, and 21 is rounded down to 20, and not both the products, sorry. One of them was rounded up, and 40 makes more of an impact because it's rounded 2 up. So the exact answer would be a little higher than 800. Next, estimate by rounding the first and then multiplying. 62 times 9 and 14 times 47. Take some time to solve these and then discuss with the people around you. After that, we'll discuss all together. You get 5 minutes. It has been 2 minutes. Does anyone need more time? I think these are relatively easy. Let's move on. For the first one, 62 would be rounded down to 60, and 9 would be rounded up to 10. 62 is rounded down because 2 is less than 4, so it's rounded down to 60, and 9 is rounded up to 10 because 9 is the only digit and it is greater than 5. Now 60 times 10 is 600. What we did here is we multiplied both of our roundings. 62 became 60 and 9 became 10. We multiplied those two and got 600. Therefore, 62 times 9 would be about or approximately 600. Next, 14 would be rounded down to 10 because 4 is less than 5, and 47 would be rounded up to 50 because 7 is greater than 5. 10 times 50 equals 500. We multiplied 14 became 10 and 47 became 50. We multiplied 10 and 50 to get 500. Therefore, 14 times 47 would be about or approximately 500. Again, you can use about and approximately interchangeably. In estimation, they mean the same thing. These are just some examples of possible rounding choices. It is all right if your answers differ a little bit. For instance, on the second problem, some may have rounded 14 up to 15 because numbers that end in 0 or 5 are easier to work with. So you may have rounded it down to 10 or up to 15. 10 might be easier because it ends in 0, but 15 is also relatively easy to work with because it ends in 5. So your answers might differ there, but it should be generally close to 500 for the second one and 600 for the first one. Now we're going to transition into division. Here we will be estimating quotients. Multiplication and division estimation work differently. With division, we look for numbers that divide easily. We call these numbers compatible numbers. For example, 198 divided by 6. Think, what number close to 198 divides by 6? The closest number that divides by 6 is 180 because 18 divided by 6 is 3, right? So we can assume that we know that 180 divided by 6 would be 30. Therefore, 198 divided by 6 is approximately 30. The number 180 was not picked randomly. It was chosen because we all know that 6 divides into 180, and then when it's divided into 180, it comes out without a remainder. The remainder is 0. Could I use 210 instead? Why or why not? Take 1 minute to discuss with the people around you, discuss with your classmates, and I'll tell you the explanation. Okay, we're going to move on now. I'll tell you the answer. Yes, 210 could in fact be used because it is close to 198 and it is also divisible by 6. 210 is divisible by 6 because we know that 21. Hold on 1 second. It's divisible by 6. However, 210 is farther from 198 than 180 is, so using 180 would give a more accurate estimate. 198, if you need help with this, 198 minus 180, what is that? That's 18. However, 210 minus 198, that is 12. So they can both be used, except 180 is easier to use because let's remove the 0, let's divide it by 6. It equals 3. Therefore we know that 180 divided by 6 is 3. Now 210 divided by 6, we know that it's divisible by 6, but only if we do the work. 210 divided by 6 is 35. But if we got rid of the 0, 21 isn't divisible by 6, so we might not know that right away. So 180 would be easier and it'd be more accurate. Also, this symbol over here, it looks like an equal to sign, right? Except it's more curvy. It means almost equal to, and it can be used as a shorter way of saying is approximately or about. So far, you have been saying for your answers, let's use this one. 180 divided by 6, you would say it's about 30 or approximately 30. However, over here, you can, if you're writing it, you can just use the sign and it means the same thing. So it's easier to write. It's faster to write when you're writing it down. If you're saying it out loud, you would say approximately or about. Here, 403 divided by 8, and then this, you need to practice saying this. It's is approximately 400 divided by 8 equals 50. 403 got rounded down to 400 because 400 is divisible by 8. And when it's divided by 8, it equals 50. So that means 403 divided by 8 is approximately 50. Here we have 95 divided by 5. That is approximately 100 divided by 5 equals 20. We rounded 95 up to 100, and 5 is left as 5 because that's the divisor. This is division. Now 100 divided by 5 is 20. On the first problem, 403 is rounded down to 400 because 403 is not divisible by 8, while 400 is divisible by 8 and is closer to 403. On the second problem, 95 is rounded up to 100 despite already being divisible by 5. You see, 95, it ends in a 5, so it's divisible by 5, but we still rounded it up to 100, right? Why do you think that is? Discuss with your classmates, talk to your classmates, and decide whether it is why we rounded it up to 100 rather than leaving it as 95. Okay, let's discuss together now. 95 was rounded up to 100, even though it is already divisible by 5. That's because 100 is easier to work with and it is close to 95. Because it is close to 95, we were able to round it up to, because if it ends in a 0, it's easier to work with than it ends in a 5. Although zeros and fives in the ones digit place are already easy to work with, it's much easier to work when there's a 0 in the ones digit place. So if you were asked to divide 95 divided by 5 and 100 divided by 5, you would be able to do 100 divided by 5 faster because you know that 10 divided by 5 is 2. So 100 divided by 5 must be 20. Therefore, it is easier. However, if you're doing 95 divided by 5, it would take longer to think and it would give you the exact answer, yes. But this is estimation and it's about estimating, not getting the exact answer. So you can do things like that too. Because it was close to 100, we were able to do that. Here's some independent practice. Y- Estimate 49 times 18, 203 times 6, 612 divided by 3, and 95 divided by 4. Work on estimating these problems and discuss what rounding choices you made and why you made these choices with the people around you for 6 minutes. I'm going to go back to the rounding slide really quick. Remember these steps. You have to look at the digit to the right. If it is 5 or greater, round up, and if it is 4 or less, round down. You will get 6 minutes to work on this now. Your time starts now. If you finish early, then talk to the people around you and discuss why you made those choices, how you got that answer. halfway through the time, 3 minutes. Now, 3 more minutes left. If you have already finished, you can discuss with your classmates. Charger, charger. Honey, get me a charger, quick. Okay, time's up. 49 times 18 is approximately 550 times 20. 49 was rounded up to 50 because 9 is greater than 5, and 18 was rounded up to 20 because 18 is greater than 5 also. So now our two new numbers for the estimate are 50 and 20 multiplied together. That makes 100. Then 203 times 6, that's approximately 200 times 5. 203 was rounded down to 200 because 3 is less than 5. And then 6 was rounded down to 5 because 5 is also an easy number to work with. That's 1000. 612 divided by 3 is approximately 600 divided by 3 because the closest, the easiest and closest number to 612 that's divided by 3 is 600. 612 is also divisible by 3, but it's easier to use 600 because we know that if we take out two of the zeros, we know that 6 divided by 3 is 2. So 600 divided by 3 must be 200. Next, we have 95 divided by 4, which is approximately 100 divided by 4, because 95 can be rounded up to 100, and it's pretty easy math to know that 100 divided by 4 is 25. That's common knowledge. However, you could have also rounded the 4 up or down. You could have rounded the 4 up to 5, and you could have done 100 divided by 5, which is around 20. That's also close to 25, so that's also a good estimate. Okay, next. Now it's time to compare and reflect. Take a minute to think. Were your estimates reasonable? Would they be would the exact answer be higher or lower? Estimation isn't guessing, it's reasonable thinking that helps us to check the accuracy of our answer when we do the exact calculations. In your opinion, which was easier to estimate, multiplication or division? Take a minute to discuss with the people around you. Next, take a minute. Okay. Whoops. Okay, next. Estimation. This is the final takeaway. This is what to remember. Estimate before solving. That's very important because if you estimate after you solve the exact answer, it doesn't help you very much. And you have to use rounding, multiplication, or compatible numbers with division. When you round, you use multiplication because, sorry, when you use multiplication, you have to use rounding because you need to round both the numbers. However, in division, compatible numbers means numbers that work well together. For example, in the instance of 302 divided by 6, we would round 302 down to 300 because 300 and 6 are compatible numbers. The third bullet point is that estimation helps check if our answers make sense. Let's say you're doing a problem, right? And you get a number that is far off from your estimation, then you will know that you did it wrong, right? It's what I meant in the first slide by a safety net. It helps you check your answers well. And exact answers should always come after you estimate. After you estimate, you should calculate the exact answer so that you can see if it's close or far from your estimate so that you know whether your answer is accurate or not. Remember, when you estimate first, your brain already has a target and you have a relative idea of what kind of number to expect after you finish solving. In math, both being exact and being reasonable are important. However, being reasonable helps you narrow down your exact answer, and it is helpful to use if you estimate first to determine the reasonability of your exact answer. So basically, what this means overall is that if you estimate first, you will know what your answer should be around, and when you do the exact calculations, you can check your work based off the estimation to see if the calculated answer you got is close or not. Okay. Now we will be learning and understanding figurative language. We will identify similes and metaphors and tell the difference between them. By the end of this lesson, you should be able to listen to a sentence and tell whether it uses a simile or metaphor. You'll also be able to try writing one yourself. So this is we're transitioning into English if you haven't noticed. Similes and metaphors are types of figurative language to clarify. And figurative language is when writers use words in a creative way to help readers picture ideas or feelings, but they're not meant to be taken literally. Basically, figurative language is when writers use words in a creative way and they help readers picture ideas. They're not literal, meaning that they shouldn't be taken down straight down to the exact meaning of what it says. It like let's say you're reading a book, um okay, let's say you're reading a book, it would be more fun to read a book with figurative language rather than when the book tells you everything straight. Like it was if they describe it as it was hot or it was big or it was cold. Rather than that, instead of saying it was hot, you could say it was as hot as a fire. That's more interesting to read, right? Instead of saying it was cold, you could say it was as cold as ice. That's also more interesting to read. Figurative language is used by writers to make their writing more interesting to read. Instead of just stating facts, writers sometimes compare things to help us see ideas in our mind. For example, if I say, I'm so hungry I could eat a horse, do I really mean a horse? Of course not. I'm not going to actually eat a horse. However, it means that I'm very hungry. Not hungry enough to actually eat a horse, but it's an exaggeration in figurative language that makes the writing more interesting to read instead of just telling straightforward. Why writers use figurative language? First of all, it makes writing more interesting, and it helps readers imagine. It also conveys feelings and ideas. Based on what kind of figurative language is used and how it's used, it can convey the writer's emotion to the readers, and it helps the readers imagine it better. Writers use figurative language to paint pictures with words. This means that when figurative language is used, you will find it easier to imagine what the writer is talking about in your head. It also helps the readers feel something instead of just reading plain facts. For instance, would you rather read the day was hot or the sun was a blazing fire in the sky? The second one is much more interesting because it uses figurative language. Figurative language can also be used in everyday speech. For example, the saying it's raining cats and dogs means that it's raining really hard. It doesn't actually mean that it's raining cats and dogs. So you can hear these phrases that don't, I'm sure you've heard phrases that don't literally mean what you're saying, but are used in everyday speech to make the sayings like instead of just straight out saying something like the day was hot, you could say it's as hot as the sun, right? It's more interesting if you say it that way, whether you're writing or talking. Next, what is a simile? A simile is a type of figurative language that directly compares two different things, often unlike, to create a vivid description, typically using the words like or as to highlight their similarities. Basically, what this is saying is that a simile is a type of figurative language. We learned about figurative language here, right? It makes words more interesting and it's creative and it's not taken literally. A simile is one section under that big topic of figurative language. Figurative language is the whole topic, and a simile is one example under that topic. Similes compare two things using like or as. For example, if I say the sun is like a lamp, that is a simile, because the sun is being compared to the lamp using the word like. The metal was as cold as ice is another example. The metal is being compared, the coldness of the metal is being compared to ice. Whenever you see two things being compared using like or as, you see these words, they're darker than the others, like and as, you automatically should know that it is a simile. In the first example, the sun is being compared to a lamp using the word like. In the second example, the metal's coldness is being compared to the ice using the word as. Therefore, these two are examples of simile. Some more examples of similes are that she ran like a cheetah, or he crept like a mouse. Here is a picture of a girl running, and here is a picture of a boy sneaking. Here is a picture of a cheetah, and here is a picture of the mouse. There are arrows here saying that the girl is being compared to the cheetah, and the boy is being compared to the mouse. These sentences don't mean that the person is actually an animal. It's not saying that the girl is a cheetah, and it's not saying that the boy is a mouse. It's saying that it's comparing the person to the animal. It's a comparison to help us understand how fast or quiet. It's more interesting to read and easier to imagine. In the first sentence, someone running is being compared to a cheetah. Cheetahs are very fast wildcats, so it means that the person is fast. In the second sentence, someone is creeping and they are being compared to a mouse. Mouses are known for being very quiet, so the sentence is saying that the person is very quiet. So in this sentence, in this simile, it says she ran like a cheetah. In your head, it helps you picture a girl that is running very fast, right? And he crept like a mouse. You shouldn't be imagining a boy turning into a mouse. That's silly. You should be imagining a boy going so quietly that it's like a mouse. Not it's not saying that he is a mouse. It's saying that he is similar to one. Okay. What is a metaphor? A metaphor is similar to a simile. It's like a simile, except it's stronger than a simile. They're both ways of comparing things. However, similes compare using the words like or as. It says that something is like another thing. However, metaphors say that it is literally something else, even though that we know that it's not actually true. All in all, metaphors compare two things, and it does not use the word like or as. It says one thing is another. So basically, we have this example here. It says the classroom is a zoo. That's not saying that the classroom is literally a zoo. It's saying it's comparing the classroom to the zoo. In the above metaphor, the writer is not suggesting that the classroom was literally a zoo. It is only a comparison. Zoos are where wild animals are kept, right? So if the classroom was a zoo, the kids would be compared to the wild animals. This metaphor means that the class was wild and likely misbehaved. It is not saying that the classroom is a zoo, it's saying that the people in the classroom behave like animals in a zoo, and therefore it's comparing the classroom to a zoo. It is not saying that the classroom is a zoo, meaning that it's not literal. It doesn't use the words like or as. It's saying that one thing, which is the classroom, is another. Here are some metaphor examples. The exam was a piece of cake, and he is an open book. Here we have a picture of an exam paper and a piece of cake. It doesn't mean the exam picture turned into a piece of cake. And here, it doesn't mean that the boy turned into a book. In the above examples of metaphors, things are compared by saying that one thing is another. However, that is not true. They are just comparisons. In the first example, the exam was not literally a piece of cake. A piece of cake is just a saying that means something was really easy. If someone says that something was a piece of cake, it means that it was really easy. So in the first example, the message being conveyed is that the exam was really easy. In the second example, a person being compared to an open book. If the book is open, you can see everything in it. If the boy is compared to it, it means that he has nothing to hide and displays everything about him. Let's say you have an open book. You can easily read the things in that book, right? Because it is open. This means that if the person is an open book, it means that you can easily know things about them. They don't hide anything. So basically, the exam paper did not turn into a piece of cake. It's just a way of saying that it was really easy. It's a use of figurative language, and it's more interesting to read. It saying that he is an open book, it doesn't mean that he was actually a book. It means that he's easy to read, meaning he is easy to understand and he doesn't hide anything, like an open book, right? Okay, next. Simile versus metaphor. Similes use like or as to compare, and metaphors don't use things like or as to compare, and says one thing is another, not that it is like another. Both metaphors and similes compare things, but the words used to compare are different, and that is how you should identify the difference. Now it's time to create your own. Write one simile and one metaphor. Use these to start. A simile should have two sides. Similes and metaphors should both have two sides, except separating the two comparisons should be the phrase is like or as. For metaphors, it should be compared with is. Remember, simile is saying that one thing is like another, and metaphors is saying that one thing was another or is another directly. Take 5 minutes to write them. After you do, share your ideas with your classmates around you. It doesn't have to be perfect, focus on creativity. Some examples for similes could be she is like a sh- she is so light that she is like a feather. That is comparing the weight of someone to a feather, meaning that they are very light. For metaphor, if you say that she was a cheetah, that doesn't mean she actually was a cheetah. It means that they run fast like one, right? So here you can take your 5 minutes to write them, and if you finish early, discuss with your classmates around you, check each other's work, and you can write multiple. 5 minutes starting now. Alright, time is up. Here is your homework. You have reached the end of today's class. Good work today. I know that was a lot to take in. To make sure that you remember the information you learned today, you have some homework to complete. For math, get 10 problems, 5 multiplication, and 5 division. You can create these problems on your own or ask a teacher or parent to give you these problems. Then, before solving them, estimate it using the rounding techniques you learned today. For English, write 5 similes and 5 metaphors. Okay. I will pause on the screen for a minute so that you will get to write it down. Um, yeah, good work today.